Let's begin sections 3.2 through 3.4, solving 1- and 2-step equations. And we're going to go straight to our Cornell note sheet. We're going to write in some things for solving two-step equations. Now, when you're solving equations, our number one goal is to isolate the variable, which means get it alone, isolate it. Get it all alone on the left side, ultimately, is where we want it. So when you're solving two-step equations, we are doing the order of operations backwards. So that means we want to undo any addition and subtraction first. Okay? And then our second step then would be to undo any multiplication or division second. So we're doing the order of operations backwards. So an example, if we have 1/2 x plus 5 equals 10. One of the ways you can do this is undo addition and subtraction first by, if we're adding 5, to undo that, we subtract 5 from both sides. That makes these drop out and gives us 5 over here, and that leaves us with 1/2 x. Now, in order to get rid of this 1/2 x, we want to multiply by this reciprocal. So multiply by the reciprocal of 1/2, or multiply by the denominator is what we'll spend more time doing. If we multiply by the denominator in this case, we want to multiply the left side and the right side by 2. What we are not going to do is divide both sides by 1/2. We know that dividing by 1/2 is the same as multiplying by its reciprocal, 2 over 1. That's what we're doing here. So 5 times 2 will give us 10. The 2 and the 1/2 will cancel because 2 over 1 times 1/2, the 2's cancel, the 1's cancel, and you're left with x. And then we're going to write our answers in set notation this year anytime we solve for a variable, which says x such that x equals 10. And we can talk about that more in class. But it's a funky bracket, x such that x equals 10, close bracket. And it's got to be a bracket, not a parentheses. It says, I found x, and x equals 10. Woohoo! Okay, so let's go to our notes. One-step equations. Now, if you think you know how to do these, pause now and try to do these if you like, and then you can come back and see how you did. Now, x is being subtracted by 6. We need to get x alone, so we need to undo what's going on here. So the opposite of subtracting 6 is to add 6, and you need to do that to both sides of the equation. So these drop out. A -6 and a +6 leaves us with x, and -12 plus 6 is really subtraction because the signs are different. So 12 minus 6 is 6, and you keep the sign of the larger number, so x equals -6. We need to write this in set notation, so we add like an absolute value symbol, an x, and then brackets in the front and brackets in the back. X such that x equals -6. Okay? Now, this one is a tricky one because before you start solving anything, you need to adjust this double negative here. So anytime we have two negative signs next to each other, we do what I call make it happy, and let's rewrite it. K plus 3 equals -9. The opposite of adding 3 now is to subtract 3. So we look at the variable, figure out what's going on to it, and we have to undo that. So we get k equals -9 minus 3. That's the same as -9 plus a -3, which gives us -12. K such that k equals -12. Here, t is being multiplied by 8, so we divide by 8. And those cancel, and t equals -56 divided by 8. A negative divided by a positive is going to be a negative, and we should get 7. T such that t equals -7. Okay. Now, moving on to some that involve multiplication and fractions specifically. Now, if we look here, we know m is being divided by -7. If we want to get m alone, we have to do the opposite of that. So we're going to multiply by -7. You have to keep the sign the same. You just make the operation opposite. So the opposite of division is multiplication. We multiply this side by -7/1. The -7's will cancel here, and you'll get m. And then 21 times 7 is -147, because a positive times a negative will make that negative. So we get m such that m equals -147. Now for each of these problems, you could do a check and know that you have it right. So what you need to do is use the original problem, plug in what answer you got into the original problem. Leave everything else exactly the same. So we bring that 21 down. Then we divide this, we get 21, which does equal 21, so we know we did it right. If this answer on the left side comes out to be different from the right side, then you know you need to go back and check your work over here. Let's look at number 5. So usually when we're dealing with fractions, I always say multiply by the denominator. So the denominator is -2. We're going to multiply this side by -2 and this side by -2, if you want, 2/1. The -2 will cancel with the -2, the 1 with the 1, and you're left with just the x. And -4 times -2 is +8. Let's do a check here. 1/2x equals -4. So 1/2 times 8 equals -4. If we put 8/1, half of 8 would be 4. So the negative of half of 8 would be -4. And we know that we have it right. One-step equations. Moving on to two-step equations, we want to follow what we said. We're doing the order of operations backwards. So we undo addition and subtraction first, then undo multiplication and division second. So we know when we look at x, there are two things happening to it. We're multiplying it by 5 and we're adding 3. Now we have to undo addition and subtraction first, so the opposite of adding 3 is to subtract 3. 23 minus 3 gives us 20, and that's equal to 5x. Now 5 is being multiplied by x. The opposite of that would be to divide by 5 to get rid of those 5's, and we're left with x equals 4. X such that x equals 4. Let's check it. 5 times 4 plus 3 equals 23. So you can skip the original if you want, as long as you don't make any mistakes plugging it in. Follow the order of operations. 5 times 4 is 20. 20 plus 3 does equal 23. So the left side equals the right side, so we know it's right. You can do that on any problem here. Number 7, we are multiplying m by 7 and subtracting 17. Undo addition and subtraction first. So we add 17 to both sides. 7m, these drop out, equals 60 plus 17, which gives us 77. Now m is being multiplied by 7, so we do the opposite, which is divide by 7. Those cancel, and we get m equals 11. Moving on down, there's a couple ways we can do these fraction problems. So I'll do one way, we'll do the second one a different way. So the first way is to follow these steps, undo addition and subtraction. Now there's some confusion here sometimes. K is being divided by -4 and being added to -12. So if we want to get rid of this -12, we need to add 12 to both sides. 8 plus 12 gives us 20. And we get k over -4. Now k is being divided by -4, so we multiply through by -4 over 1, multiply by -4. These will cancel, and you're left with just the k on the right side. -4 times 20 would give us -80. Now for set notation, k must be on the left, so you have to rewrite this one. You can't just add the k's in the front. So you can't go like this, k such that -80 equals k. That's wrong. You have to rewrite it with the k on the left side. So that is following these steps here. Let's try it the other way. The other way is to multiply everything by the denominator. So if it has a fraction in the problem, you could multiply everything by the denominator. Okay? And we can go ahead and write that on our Cornell note sheet. Solving equations containing fractions. You can multiply everything. Underline that. Everything, everything, everything by the common denominator. Okay. So we'll go ahead and fill in an example in a little while. Next section possibly. Okay. Now, so in this case, 8 is the denominator. So we can multiply this by 8 over 1, this by 8, and this by 8. Everything means everything. So we multiply this by 8 over 1. The 8's will cancel. This is supposed to be a 1 right here. Oops. And we get 1p left over, which you can write as p if you want. Minus 4 times 8, so that's minus 32. And 10 times 8, which gives you 80. So when you multiply everything through by the denominator, which is 8, all the fractions drop out. And then we can, in this case, just undo the subtraction by adding 32 to both sides. P equals 112. P such that P equals 112. Okay? Let's also add to our Cornell note sheet, checking my solutions. You plug the solution into the original and see the original problem and see if it works. So if we want to multiply everything through by a common denominator, I'm going to show you another example of that. You can write this on your Cornell sheet. So we have a denominator of 5. If we multiply everything by 5, in this case 5 over 1, that would give us negative 4y plus 5 times 7, which is 35, 5 times 23, which is 115. Then you can finish, undo addition and subtraction, and move on. Keep finishing the problem. Now, for checking your solutions, you could, let's suppose the problem said 1/2 x plus 5 equals 10. And you got, for your solution, x equals 10. You could do 1/2 of 10 plus 5 equals 10. And that would be 5 plus 5 equals 10. Don't move anything left to right. Just keep bringing this guy down and just simplify this side. So 10 equals 10. So we know that it will work. Okay. Let's go to the back of our notes here and see what we've got going on here. Why don't you take a break and from me and try these two problems on your own. So let's see how we'll do these. 8x is being multiplied by 8 and added to a negative 4. So we need to undo this first. That 4 is negative, so we're going to add 4 to both sides. 4 plus 4 gives us 8. These drop out, and we get 8x. Now, 8 is still being multiplied by x, so we want to undo that by dividing by 8. And anything divided by itself would be 1. That's the identity property. And so we get x equals 1, but you have to rewrite this, x such that x equals 1. Now here, I'm going to multiply through by the common denominator, so multiply everything by 8, by 8, by 8. Sometimes it's easier here to put it next to it. This one's slightly different than the last problem, so let's see what happens. The 8's will cancel, and you're left with 7p. minus 4 times 8, which is 32, equals 10 times 8, which is 80. Now undo addition and subtraction. So we undo this minus 32 by adding 32. We get 7p equals 112. When we divide by 7 to get rid of that 7, we get p equals 16. P such that p equals 16. How did you do? Did you get 2 out of 2? All right. Moving on to the next section. On our Cornell note sheet, we aren't quite going to move to solving equations with variables in them. Let's just continue with this thought, multiplying through by a common denominator. So in 12, our common denominator is 3, so we multiply everything by 3. The 3's here cancel, because I put 3 over 1, and we're left with 2x plus 8 times 3, which is 24, equals negative 6 times 3, which is negative 18. Now undo addition and subtraction. So we subtract 24 from both sides. We get 2x, that drops out, equals 24 and 18. 8 plus 4 is 12, raise the 1, 2, 3, 4. Negative 42, a negative plus a negative is going to give you a bigger negative. And then finish up by dividing everything by 2, and we get x equals negative 21. A negative divided by a positive will be a negative. The signs are different, and it'll be negative. If the signs were the same, it would always be positive. Let's talk about 13 and 14. Now there's still a denominator here, so we will still begin by multiplying through by the denominator. You cannot touch this top here. It's almost like a grouping symbol. That's the last thing you'll be able to do. So we're going to multiply the left side by 9 over 1 and the right side by 9. Now look, the 9's cancel, and all you're left with is p minus 15. You do not touch the p minus 15. The 9 does not get distributed through because it cancels with the 9 that we multiplied by. And then we get negative 54. Undo the 15 by adding 15. And we get p such that p equals negative 54 minus 15, 39. So once you get past multiplying through by the denominator, it's really an easy problem. Why don't you try number 14 on your own? So we've got a denominator of 5, so we multiply the left side by 5 over 1 and the right side by 5. This 5 cancels with this 5, and you're left with 4 minus 2d. And 6 times 5 is 30. Now we do have 2 steps to do here. We have to undo addition and subtraction, so don't touch that 2 yet. We need to get rid of this 4. This 4 doesn't have a sign, so it's understood to be positive. So we subtract 4 from both sides, and we get these drop out. Don't forget to bring down this negative sign. Negative 2d equals 30 minus 4, which will be 26. We have that negative with us. We need to divide by a negative 2. Those will cancel, and we get d equals negative 13. D such that d equals negative 13. Now, if you had any trouble with any of these problems, remember you can always rewind and go back and walk through the problems again.